Hi, this is Madison Mullen, and today I'm going to be talking about an article titled Muscle Strength, Power, and Morphologic Adaptations After 6 Weeks of Compound versus Complex Training in Healthy Men. This was an article that was published in the September 2015 Journal of Strength and Conditioning Research, so it's brand new. And this is all under our topic of this week for evidence-based practices in exercise prescription and programming. So to give a little bit of background, just before we kind of launch into this specific study about what we know from evidence that are results of proper resistance training, we know that proper resistance training programs improve both muscular strength and power, and that's a result of both neural and muscular adaptation. We have a lot of evidence that supports that conclusion. We also know that concurrent strength and power training has been found to be equally, and if not more effective in increasing muscular power than just power training alone. And I think that, that kind of body of research is probably what inspired the study that we're about to look at. So there are a lot of ways to train and combine strength and power together. But two of those is compound training and complex training. So the research question that Stasinaki and the rest of the authors are asking in this particular study are, what are the effects of complex and compound training programs on whole and lower body muscular strength and high-speed movement performance, or power, in athletic and healthy individuals? So complex training in this case is referring to combining strength and power in a single exercise session, whereas compound training is separating strength-focused exercises on one day and then on an alternative day to do power-focused exercises or power-focused training regimen. All right, so specific methods that Stasinaki and the other authors kind of took for this particular study. They used 25 moderately trained males. They were all around college age, so average age was 21.9 years of age. And they divided those subjects into three groups. So the first was compound training, and that group was going to train 3 times a week for 6 weeks for the course of the study. The second group were complex training, so combining the strength and power in a single exercise session, and they were doing that for 3 times a week for 6 weeks. And then finally, they had a control group to compare to. Stasinaki was going to determine those differences in strength and power, as well as muscle architecture and morphology, on the following kind of tests. So at the beginning and the end of the study, they did counter movement jumps and backward overhead throwing. So that's a vertical jump with, a squat at the bottom and a standard shot put. And that evaluated subjects' power. They used 1 repetition max in the 3 program exercises. So they only used 3 exercises for the duration of the 6 weeks. And they looked at 1 repetition max changes over the course of the study to evaluate strength. They did ultrasounds of the vastus lateralis and gastrocnemius to look at muscle architecture changes. And then they also did biopsies of the vastus lateralis to look at fiber type and cross-sectional area. Okay, so launching into the actual study part. So both experimental groups, as I had mentioned before, only did 3 exercises the entire course of the study, and that was the incline leg press, the bench press, and the Smith box squat. And so if you look at table 2 on the right, you can see that the left side, the left column, describes the compound training group's regimen, and the right side, or the right column, is the complex training group regimen. And so compound, the day 1 was when subjects focused on strength. So they were doing higher percentages of their 1 rep max in all of those exercises with fewer repetitions because the intensity was much higher. And then on day 2, they were training for power, and so they were using a lower percentage of their 1 rep max and doing higher repetitions, so 6 versus 8. If you look at the complex column, they actually alternated between strength and power in each exercise. So they would do 6 repetitions at 85% of their 1 rep max, and then would decrease the intensity significantly and do 8 repetitions of the same exercise. And they did that 3 times a week for the duration of the 6 weeks. For both groups, too, it's important to note that training loads were increased as they became stronger to maintain that percentage of their 1 rep max. So results. So I have two slides on the results here. Let's first talk about the performance training, the power training. So at the beginning of the study, they did the jump and overhead throwing. And then at the end of the study, they also did the jump and overhead throwing to see how power increased for the subjects following both of the training groups. And they actually found that the compound training group significantly increased their performance in the power exercises, but not in the complex group. So that was pretty interesting. Separating strength and power resulted in greater power improvements or performance in power than interspersing them or intermixing them. In terms of 1 repetition maxes, so strength improvements, both groups got stronger over the course of the study, which isn't unexpected, but the squat and bench 1 rep maxes increased significantly higher in the complex group, so combining the strength and power together. And then if you look at table 3 on the right, there were significant increases in vastus lateralis thickness in both training groups, but the percent change in vastus lateralis thickness was greater in the compound group. All right, I hope you guys can see this graph on the right, because this is kind of where things get interesting, at least in my opinion. So the first group of bars on the right is the compound group. You can see kind of small printed there, but CPD, that represents the compound group. In the middle, CPX is our complex group, and then at the bottom we have control. So this is all cross-sectional area that we're looking at from before and after, as well as fiber type. And so actually, let's look at the complex results in the center, because that's really where a lot of the interesting stuff happened. So the percent increase in type 1 and type 2 fiber cross-sectional area was significantly higher for the complex training group as compared to the compound training group. And the percent increase in training volume was also significantly higher for the complex group when compared to the compound group and obviously the control group. So in terms of muscle hypertrophy, complex training was much more effective in this case. And you can see that from the increase in type 1, type 2, and even type 2X fibers there. So general conclusions that we can kind of draw from this study, or at least ways that we can sum up the results. So first, high-speed movement training or power training, or I guess explosive muscle performance, was better improved using compound training, so separating strength and power. And then strength was actually better improved when strength and power were trained in the same session. And then, as we looked at on the previous slide, complex training actually results in greater muscle hypertrophy when compared to compound training. So pretty interesting. Not what I was expecting in terms of results. But the real question, I guess, is how do we apply this to the evidence-based practices that we're talking about this week? And so, obviously, this study could have valid implications for training specificity. So if we're working with a particular sports team, we could absolutely use this research to say, okay, well, we're trying to improve strength, and that's our main goal, so we're going to employ complex training. Or if we're trying to improve explosive muscle performance, then I'm going to employ compound training with my group. to accomplish the things that we want to. But I think when you look at it through the light of evidence-based practices, as Dr. Alvar had discussed in his presentation, evidence-based practice is a systematic process, and it requires, consistently going back to the evidence and continually learning and asking questions and not just taking things at face value. And so that means that we rely upon evidence for our decision making, and not just any evidence, but we consider the quality, the relevance, the importance, and the prevalence of evidence before we formulate a decision and, employ one technique over the other. And so just because one study says, complex training is better for muscle hypertrophy than compound training doesn't mean we just employ it, right away. But we ask questions, we delve deeper, we continue to learn until we have a really significant body of evidence, and we can, use the evidence to accomplish what we want to in a safe and effective way it's based on validity and accuracy. So actually one previous study, only one, has ever been done comparing compound and complex training before the current one, before the one we just discussed. And, they found similar results among college volleyball players in terms of comparing complex and compound training. But I still think that, further evidence is needed before we make any definitive conclusions about, which is significantly better than the other, or if there really are, significant differences for the untrained person or that kind of thing. And here is a reference for this article if you're interested in looking at it on your own. Otherwise, thanks so much for listening and have a good one.